Welcome to the most epic crash course in physics you've ever seen. Buckle up, because we're about to dive into the universe's secrets. From the tiniest particles to the grandest galaxies, physics is the key to everything around us. Before we start, don't forget to like and subscribe to BrainBytes Pro for more insightful resources. Let's get started. The basics of physics. Physics is the science of matter, energy, and the forces that shape our universe. Everything we see, feel, and touch is governed by physics. Imagine a world without it, chaotic, unpredictable. Physics keeps things in order, whether it's a falling apple or the movement of stars. But where does it all begin? Classical mechanics. Let's start with classical mechanics. Think Newton's laws: apple falling, objects moving, planets orbiting. Isaac Newton gave us a roadmap to understanding motion. First law: an object at rest stays at rest, and an object in motion stays in motion unless acted on by an outside force. Simple, right? But it's what makes everything tick. Second law: force equals mass times acceleration, F equals ma. This explains why it's harder to push a car than a bike. More mass means more force needed. Third law: for every action, there's an equal and opposite reaction. So when you push on something, it pushes back with the same force. Energy and conservation laws. Now, let's talk about energy. Energy is the ability to do work. There are different types: kinetic energy, movement, potential energy, stored energy, thermal energy, heat, and more. One superpower of physics: the conservation of energy. This says energy can't be created or destroyed, just transformed. So when you throw a ball, its energy changes from potential, when you hold it, to kinetic, as it flies through the air. Thermodynamics. Next, we enter the world of thermodynamics, the science of heat and energy flow. Ever notice how hot drinks cool down and cold ones warm up? That's the second law of thermodynamics. Entropy. Basically, things naturally move from order to disorder. Think of your morning coffee. Heat travels from the coffee, high energy, to the air, lower energy, until they balance. That's physics in action. Electromagnetism. Electricity and magnetism, two of the most powerful forces in the universe, are all part of electromagnetism. Everything from your phone to lightning, all happens thanks to the interaction of electric fields and magnetic fields. Maxwell's equations, don't worry, we're keeping it simple, show how these forces work together to create light, radio waves, and more. Relativity. Hold on tight, because here comes the mind-bending world of relativity. Einstein's special relativity told us that time and space aren't as absolute as we thought. Instead, they bend and stretch depending on how fast you're moving. For example, if you were traveling at the speed of light, time would slow down for you compared to someone standing still. So weird, right? Quantum mechanics. Now, we enter the tiny world of quantum mechanics, where things get super strange. At the atomic level, particles like electrons don't behave like tiny balls. They act more like waves, sometimes here, sometimes there, until you observe them. This is called wave-particle duality. But wait, there's more. The Heisenberg uncertainty principle says we can't know both the position and velocity of a particle with total precision. What? That's right, at the quantum level, uncertainty is built in. The Standard Model and forces of nature. Physicists have pieced together a model to explain the fundamental building blocks of the universe, the Standard Model. It's made up of particles like quarks, leptons, and the Higgs boson, the God particle. These particles interact via four fundamental forces. 1. Gravitational force, responsible for pulling objects together. 2. Electromagnetic force, what makes your phone work. 3. Weak nuclear force, responsible for radioactive decay. 4. Strong nuclear force, what holds the nucleus of atoms together. Gravity and black holes. Speaking of gravity, this force keeps us grounded on Earth and keeps planets orbiting stars. It's a force that warps space-time itself. This is why light bends near massive objects, like black holes, where gravity is so strong that nothing can escape. Cosmology and the Big Bang. Let's step back for a moment. Our universe is vast and constantly expanding. We're all part of a bigger picture. According to cosmology, the universe began about 13.8 billion years ago with the Big Bang. From a tiny, hot, dense point, it started expanding and cooling, forming galaxies, stars, and planets. But the universe is still growing, and scientists are studying its mysterious fate, including dark matter and dark energy, which make up most of it but remain invisible. The future of physics. Where's physics headed? We're on the edge of new discoveries, like quantum computing, where quantum bits could solve problems way faster than traditional computers. Plus, physicists are still chasing the Holy Grail, a theory that unites quantum mechanics and gravity, called the theory of everything. Could we unlock the universe's deepest secrets? Maybe soon. Outro. From the smallest particles to the farthest galaxies, physics is the language of the universe. It's always asking questions, pushing the limits of what we know. And the best part? You don't have to be a physicist to appreciate the wonders around you. The world is a living, breathing experiment. Thanks for joining me on this wild ride through the cosmos. Don't forget to like, share, and subscribe for more mind-blowing insights. See you in the next one.